All right, first thing. Next two units are going to dig real deep into facts about triangles. All right, probably most of the facts, other than they have three sides and their angles add up to 180 degrees. That's probably as far as we go in here. All right, we're going to dig real deep into triangles, this unit and unit 5. Today's a basic day. I just want to gauge where your vocabulary is, types of triangles. First set of triangles are triangles that I can name by sides. So look at that first one. I put hash marks on all three sides, meaning all three sides are congruent. What do I call a triangle where all three sides are congruent? Just go ahead, yell it out here today. Equilateral, yep. Equilateral. Okay, now only two sides are marked congruent. Isosceles. And you'll notice on the third one, no hash marks are put there because no sides are congruent. So, scalene. This is how all three can be named using sides only. Sides only. All right, well, what if I don't know anything about the sides, but I do know something about their angles? I can name triangles based off their angles. Now, before I name this first triangle, which is probably brand new to you guys, we know all three angles add up to 180, so if they're all congruent to each other, anybody give me the measure of one angle? 60, yes. So if all three angles are equal, they're 60 degrees, we call that equiangular. You could also get away with calling it equilateral too. Okay, because if all three angles are equal, that implies all three sides are equal as well. Okay? You guys have what, 105 written in here? Okay? So I have a 105-degree angle there. Anybody know what type of angle 105 is? It's bigger than 90, so it's called obtuse, which means this is an obtuse triangle. And some people ask, well, what if you have two angles bigger than 90? That's called impossible, okay, in a triangle, because they only add up to 180. I can't have two angles bigger than 90. We good so far? And then, here we go. This one's a tough one, I know. Your classic right triangle. And then what do you guys have? 70 and 30, correct? And then 70 degrees and 30 degrees are acute, so we call that an acute triangle. Okay? So all four of those are just solely based on the angles. Questions from you guys before we get to the algebra part of this? All right, so let's reintroduce some terms, but now in a triangle. So point M, well, first of all, before I even get into what's given to you, everyone see the diagram, what's already marked for you. KM and ML are congruent. Now I'm telling you that M is also the midpoint of JL. M is the midpoint of JL. So is there anything else you could put on your diagram? $20 is what? Congruent, correct? All right, so watch, ready? These two are already given congruent. I'm marking these congruent. By substitution, what do you got for me? JM is also congruent to KM. Perfect. The question is, triangle JKM. Find those vertices. JKM. Equilateral, isosceles, or scalene. Well, right now, it's isosceles. But I still have to check to see if it's equilateral or not. How can I do that? Well, this was 1.5. What must JM and ML be then? If that was 1.5, now I'm going to go to you guys. 3. 0.75. Nice job. And what did we know about JM and KM by substitution? They're equal, so that must also be 0.75. So what are you going to tell me about triangle JKM? It's equilateral. Hey, I don't know if you've ever done this or seen this before. Instead of writing the word triangle, we can put triangle JKM. We're going to do a lot when we start proofs next week with that. Is equilateral because, what's a good reason? All sides are congruent. Yep. All good. All right, this next one. It's isosceles. What's the length of all the sides? Find the lengths of all the sides. Now, here's what I get. This really, really fires me up. Kids see the sides. They'll take 9x minus 1. They'll add it to 4x plus 1 and add it to 5x minus 0.5, and they set it equal to 180. What's the 180 for? Angles, not sides. It is not for the sides. I think they do this just because they feel like they have to involve all three sides in the equation. No, you don't. And that's what I'm trying to show you here. You do not have to involve all three sides when you set up an equation to solve for x. So I know these two sides are congruent. What equation can you set up for me? 16, what equation can you set up for me? Oh, perfect. How about 10? What equation can you set up? 4x plus 1 is equal to 5x minus 0.5. I'll let you guys solve for x. Just those problems, nothing else. Sure. When you have that, take your time. When you have that, let me know. 6, when you have it, let me know. 1.5, perfect. Now it says find the side measures. So now I'm going to take 1.5 and plug it in and find the lengths of AC, BC, and AB. And hopefully you're finding out 2 of the 3 sides are equal because it was isosceles. So when you're ready, let me know. 7, when you're ready, let me know all the side lengths. 7, yep. Also 7, yep. And AB, 12.5. Nice job. Questions? All right, one small thing to finish up, and that is let's place a triangle on a graph now and tell me what type it is. So I'll let you guys graph it, label it. All right, now I have a question for you guys. Find the measures of the sides. How are we going to pull this one off? We're going to use something from Unit 1 that allows me to find the length of DE, EF, and FD. Distance formula, yes, to find the length. So let's review that formula real quick before I let you tackle it on your own. Big square root, if you remember. Now let's try to put our heads together. What is under that square root? Parentheses that are squared. Anybody remember anything else? Charlie, what do you have? There we go. And you just remember, when you use distance formula, the order of the x's does not matter because after you square it, it'll always be positive. All right, so what you are going to do right now, either on your own or in your group, doesn't matter. I'll give you about 5 or 6 minutes. You're going to find the length of DF. You're going to find the length of DE. And you're going to find the length of FE using the distance formula. Now, we are in what class? Honors. So we will be leaving these lengths in simplest radical form, if possible. Meaning break down your radical at the end if you can. I will just give you a hint. 2 out of the 3 can be broken down. 1 length cannot be broken down, so you're going to leave it under the radical. All right, so I'll give you 5, 6 minutes right now. Work with your group by yourself. It's up to you. But please leave your lengths in simplest radical form. Okay, ready? DF. DF. What did we end up getting for DF? 9. What did we end up getting for DF? Correct. You had square root of 45 originally, and then you broke that down into 9, a perfect square, times 5, and that's where the 3 radical 5 was produced. Good? All right, how about DE? DE, 22. Square root of 113, that was the one that could not be broken down any further, so I leave it as the square root of 113. And then finally, we're going FE, 11. Okay, we got the square root of 104 first, and that could be broken down into a perfect square of 4 and radical 26, and that is how the 2 radical 26 was produced. Any questions on finding the sides before we find what type of triangle it is? All right, so I have 2 radical 26. I have radical 113 and 3 radical 5. Are any of those congruent? Nope. So we'll say that triangle DEF is scalene. Yes. Triangle DEF is scalene. Didn't say explain, so I'm just going to leave it. And really, here's our explanation right here, all that work we just did with distance formula. You will have to do that tonight, again, in the book, simplest radical form. If for some reason you need a sheet of graph paper to graph it on, I got a bunch right up here on the front table. Grab one, grab a slice before you start, and let's get going. I'm giving you plenty of time here, 10 minutes to start the homework.